All right, welcome back to another lesson. I know you're thrilled, so we're sketching polynomials now. A sketch, it's important to know the difference between a sketch and an actual graph. Sketch is just a rough graph, really. We're just kind of getting the rough features. So there are kind of some pieces of information that are necessary in order to graph that. You don't need any of these in any specific order. You don't need to find any of these in any specific order. So pieces of information you'll need are, like, you need the y-intercept, you need the x-intercepts, and then the behavior of each one. What that means is, does it like bounce like or touch the x-axis, or does it actually cross through the x-axis? You also need your end behavior. Otherwise, you are good to go. You're golden. You don't need actually anything else. We don't need to actually find where like the local maxima or the local minima are or anything like that. This would be enough to give us like a rough sketch of what the polynomial should be. Okay, so in order to find all of these, let me actually give an example, and I'll kind of show through this example how you find each of those pieces. Okay, so once again, it doesn't matter what order you find all the stuff in. If the equation is in factored form, like this problem is, I like to find x-intercepts first. So it's already in factored form. X-intercepts are really easy. What you're doing is you're actually setting for x-intercepts the whole equation equal to 0. So you're trying to figure out what would make this entire equation 0. In fact, x-intercepts are really hard to find unless you're in factored form. That's actually the reason we put it in factored form. Because here's the deal, when it's in factored form, we just need to find what's going to make each factor equal to 0. Because if we do like, if we put, so for instance, this factor right here, x plus 3, we want to figure out what's going to make that 0. If you solve, you get x equals negative 3. The reason this works is because if we plug negative 3 in for x, negative 3 plus 3 is 0, and then this 0 is being multiplied by the negative 2 and this x minus 1. So the entire equation will end up being 0. So same thing over here. We're going to figure out what makes x minus 1 0, and that's going to be one of our other x-intercepts. Okay? Now, when we talk about behavior, once again, I talked about how your behavior, you're either going to, if I can spell behavior, you either cross through the x-axis or you touch it, which I also call a bounce. Okay? So I'm going to show you what each one of those look like. So for instance, an x cubed function, y equals x cubed, crosses through the x-axis at 0. While a quadratic, so x squared, bounces or touches the x-axis. It actually doesn't go through the x-axis. Okay? Well, it's actually really important that those two graphs are like that, because this exponent actually is going to tell us what the behavior is going to be. So if we look back at the exponent of each factor, that's going to tell you what the behavior of that factor is going to be, because that's actually your multiplicity is what it's called. That's how many times this specific factor occurs in this equation. So the multiplicity is 2 in this for x equals negative 3. Therefore, since it's 2, it's going to act like the x squared function where it's going to bounce or touch. So I'm going to put a little b for bounce. Well, if you look at the exponent for this one right here, it's a 1. Therefore, this one, the multiplicity is 1. Therefore, it's going to cross at that x-intercept. So if we eventually make this sketch, which I'm just going to go ahead and start, as we find our information, I'll just put it on the graph. So we've got negative 3 right here. We've got 1 right here. At negative 3, I'm just going to make a mark that's going to bounce, while at 1, it's going to cross. Okay, next piece of information we need is the y-intercept. This is really easy. All you do is you replace all the x's with 0, and then you solve the equation. Okay, so for this one, we get negative 2 times 3 squared times negative 1. So that's negative 2 times 9 times negative 1, which is 18. Okay, so our y-intercept's at 18. This is a sketch, remember? So I'm going to go over to my graph. I'm just going to go somewhere on the positive y-axis. I'm going to say that's 18. And then the last thing we need is our end behavior. So end behavior, when it's in factored form, is not as easy, but it's still pretty easy. So what I do, I'm going to go back, I'm going to just rewrite all this. We've got negative 2x plus 3 squared, x minus 1. So what I do is I actually take the very first term I have, and then I multiply it by each, well, essentially, actually, let me rephrase that. I essentially just take out any of the terms that we're adding at the end. So it's like I ignore, I'm going to use black. I'm going to ignore that plus 3 and that minus 1. So anything added in there, I'm just ignoring. And I'm just going to multiply everything else together. So I'm taking the negative 2 times the x squared times the x. Well, that's negative 2x cubed. Well, it's a negative leading coefficient, so my right arrow's down. But it's an odd degree, so they switch directions. So our end behavior is going to be up, down. So that means if I go back to my graph, the farthest left point, it's going to be going up and to the left, while on the farthest right, it's going to be going down and to the right. And then you just connect. So it's going to bounce off, so it bounces off, and we go to that 18 and cross on through and pretend that crossed through, and we're done. We got our graph.